So at the top of page 185, you can highlight quadratic equation. We are going to solve equations that have an x squared. And quadratic equations come in this form. Something squared, you could have a number in front of it, plus something times x, plus something. A, b, and c are just numbers. And you can solve them. And you can always make them equal to 0. So if I had this question in blue, x squared minus 5x, a number squared minus 5 times that same number is 6. What could the numbers be? Well, if we make it equal to 0, right at this point in blue, we're adding and subtracting. And adding and subtracting to get 0 has so many possibilities. But if we can change it to multiplying, it now gives you only two possibilities. Now that it's multiplying, two things multiplied together that equals 0, one of them has to be 0. So it could either be the first one, and if the first factor is equal to 0, then x would have to be 6. If the second one was equal to 0, then x would have to equal -1. And check it out. 36 minus 30 is 6, so 6 works. And -1 squared would be 1. Minus 5 times the -1 would be plus 5. And 1 plus 5 is also 6. So we are using something called the zero product property, which is really simple but super powerful. The really simple idea is if you have two things multiplied by each other and the answer is 0, one of them has to be 0. It's so simple that it seems like, well, why are they teaching me this in grade 11? But that simple idea allows us to now solve more complicated questions. If we can factor something, we change it from adding and subtracting to multiplying. And this zero product property only works with the 0 there, right? If I told you I have two numbers in my head and the answer is 16. Can you guess what one of the numbers?
8.
No, it wasn't 8. No, it wasn't 2. No. I'm being mean.
16.
I had 16 fifths times 5. Oh, that was mean, right? It's possible. But then if you're multiplying to anything other than 0, it could be anything, right? But as soon as it's equal to 0, one of them has to be 0. This is the zero product property, and it is very powerful. And so one of the things when you're solving quadratic equations like this one in blue, we're going to have that very first step. You need to make one side equal to 0. Because if you're going to use the zero product property, one side has to be 0. If you factor it beforehand and it's a number like 5 or 2 or 1 on the other side, it's not very helpful at all. So we can go to our first examples here. Ooh, I don't want to give away all the answers. All right, a number squared plus a number minus 56 is equal to 0. You could try to guess and check, and you might get an answer that works. However, if we can factor it, and it's still equal to 0, we can use the zero product property. And this one is easy to factor. It's x and x. And with 56, and outside and inside need to make 1. 7 and 8. And we need a plus 1. Does it make sense that your outside would have to be plus 8 and your inside a minus 7? And double check, is minus 7 times 8 still minus 56? Yes. Every time you factor, you should multiply it out quickly and double check again. Then, from here, either this one could be 0. If this one is 0, what's x? 7. If this one is 0, what is x? -8. I mean, you can make a tiny x plus 8 equals 0 equation and then be like, oh, I need to subtract 8 on both sides. You could show that work if you want to get x equals -8. I think most of you will get very quick at just being able to write the two answers. X is 7 and x is 8. And sure enough, if we check with the original question, 7 squared is
49.
49 plus 7
56.
minus 56 is 0. Wow. Minus 8 squared.
64.
Positive 64, right? Plus a minus 8.
72.
Plus a minus 8. So
Oh,
we subtract 8.
56.
56,
Yeah.
and then minus 56 is 0. It works. Notice the second one. The second one already factored. But what is on the other side?
Number.
22. That is not helpful at all. In fact, in this one, we first have to multiply this whole side out and get 3x squared. My outside is negative 18x plus 1x will be negative 17x. And then my last one's minus 6 equals 22. I can multiply it out first, and then I can bring the 22 over. 22 over on this side, minus 28 equals 0. Only if it's equal to 0 will it be solvable. This one looks like a little bit of a higher level one, right? Do you know that it would have to be 3x and x though? Because that's a prime number. So now we just have to work with 28. Something here and something here. Outside and inside need to make 17. So try, what makes 28? Pick anything that makes 28, try first. 7 and 4. So now you have the option of 7 and 4 or 4 and 7. 7 here and 4 here would make 12 and 7. That doesn't make 17. But 7 here and 4 here would make 21 and 4. 21 and subtract 4 would be 17, right? So I'm going to try that. I'm going to try the 7 here and the 4 here. I need a negative 17, so I would need a negative 21 and a plus 4. Does it give me still the negative 28? Yes. It doesn't take that long to factor, but you have to be willing to try something and test it. Does my outside and my inside work? And if it appears to work, put it in and double check it in the end, because sometimes you get those ones where it looks like it works, but when you check it, it still doesn't. I'll start with this one because it's easier. What would make x minus 7 0? 7. And this one, what would make 3x plus 4? So again, in your brain, you would do this. You would make a little tiny equation and say, I need this to equal 0. Can you do these two steps at once? Could you move the 4 over, which would give you a negative 4, and then divide by 3 to give you negative 4/3? Do you think you could do that all in one step without writing out the blue? Now, what's neat about this question, if we go back to the original question, if you plug in 7, this is going to be 3 times 7 plus 1 is 22. And this will be 7 minus 6, which is 1. And 22 times 1 is 22. If I gave you that question at the beginning of class, I don't think it would have taken too long for some of you guessing and checking to get 7. But if I told you there was a second one of 4/3, 4/3 times 3 is 4, plus 1 is 5, and 4/3 minus 6 is 14 over 3. And then multiply those together and simplify. Do you think you would have got the 4/3 one, guessing and checking? Absolutely not. I mean, if, you read a kid's book about a kid that was deserted on an island and all they could do is math problems, maybe they could figure it out eventually. It's one of the books I'm planning on writing. So, yeah, people are going to watch this video. They didn't spend the beginning of class with us, and they're like, why did that math video go dark all of a sudden? Oh well. Okay, questions in the circle.